Okay, hi everyone, welcome back to this live stream for Windows Server 2003. So I'll just share my screen. Okay, Chapter 11, Monitoring and Performance Tuning Overview. Performance is a key aspect of maintaining a reliable and responsive server environment. Windows Server 2003 includes powerful tools for monitoring system health, diagnosing bottlenecks, and tuning the operating system for optimal performance. In this chapter, you will learn how to assess server performance using built-in tools, interpret key metrics, and apply tuning techniques to improve efficiency. 11.1 Introduction to Monitoring Tools. Windows Server 2003 provides several utilities for real-time and historical performance analysis. Task Manager, quick view of running processes and resource usage. Performance Monitor, PerfMon, customizable charts and logs. Event Viewer, logs, system application and security events. Resource Kit tools, additional utilities like Logman, Type, Perf, SRVINFO. These tools help administrators detect problems early and respond appropriately. 11.1 Using Performance Monitor, PerfMon. PerfMon is a central tool for collecting and visualizing performance data. Key features: add counters for specific components, CPU, memory, disk, network, monitor in real time or log over time. Generate alerts when thresholds are exceeded, launching PerfMon. Run perfmon.msc from start run. Common performance counters to monitor. Category counter description. Processor, percent processor time, CPU, memory available MB bytes, free memory, physical disk, average disk queue length, disk congestion, network interface bytes, total SCC, network throughput, system processor queue length, threads waiting for CPU. 11.3 Establishing a performance baseline. A baseline helps compare current performance to a known healthy state. Steps to create a baseline: 1. Monitor during periods of normal usage. Log data for at least 24 to 48 hours. Record typical values for key metrics. Save perfmon templates for future comparisons. This baseline helps identify trends and abnormalities. 11.4 Identifying bottlenecks. Common system bottlenecks include CPU, high percent processor time and long queue lengths, memory, low available memory, excessive paging, disk I/O, high disk queue lengths, frequent spikes, network saturated bandwidth, high collision or retransmission rates. Use perfmon and Task Manager together to isolate problem processors or services. 11.5 Performance tuning techniques, CPU optimization, offload services to other servers, DNS, DHCP, adjust processor affinity for specific services, upgrade to multiple processors or multi-core CPUs if needed. Memory optimization, increase RAM to reduce paging, reduce memory leaks by updating applications. Use pagefile.sys on a separate physical drive for better performance. Disk optimization. Use faster disks, e.g. SSDs. Defragment regularly using disk defragmenter. Distribute I/O load across multiple drives or controllers. Rate network optimization. Increase NIC speed, gigabit where possible. Enable jumbo frames for large transfers if supported. Use quality of service QoS to prioritize traffic. 11.6 Task Manager and Process Explorer. Task Manager Control plus Shift plus Escape shows running processes and their CPU memory usage. Performance graphs. Startup programs with some tools. Process Explorer system internals is more advanced. Show process trees. Identify identifies open handles and DLLs, helps pinpoint rogue or resource-heavy services. 11.7 Event Viewer for Diagnostics. Event Viewer tracks logs in system, hardware and driver issues, application log behavior, security, logins, privilege changes with auditing enabled. Check Event Viewer regularly or use scheduled tasks to alert on certain errors. 11.8 Log management and automation. Automate performance and data collection using Logman command line tools to create and manage logs, task scheduler, run scripts based on performance triggers, alert in Perfmon, notify administrators where thresholds are crossed. Examples: alert when CPU exceeds 90% for more than 5 minutes. 11.9 Performance best practices. Avoid running unnecessary services. Use group policy to restrict background apps. Patch regularly to avoid performance bugs. Reboot servers on a scheduled basis if possible. Use server roles. Separate roles like file server, web server, and SQL server. Summary: performance monitoring and tuning are ongoing tasks that ensure your Windows Server 2003 system remains responsive and reliable. By understanding and utilizing tools like Performance Monitor and Task Manager, and by applying targeted optimizations, you can proactively manage system health and deliver stable services to users. Chapter 12: Backup and Recovery Strategies Overview. No matter how robust your server configuration is, data loss or system failure is always a risk. Having a sound backup and recovery strategy ensures that your organization can recover quickly from disasters, avoid costly downtime, and maintain data integrity. Windows Server 2003 offers several built-in tools and supports third-party solutions for effective backup and restore operations. 12.1 Importance of backup and recovery. Key reasons to implement a backup strategy: protect against hardware failure or corruption, recover from accidental deletions or overwrites, defend against malware and ransomware, support compliance and audit requirements, provide disaster recovery capabilities. A comprehensive strategy includes both data backup and system state backup, along with regular testing of restores. 12.2 Understanding Windows Backup, NT Backup. Windows Server 2003 includes a built-in utility called NT Backup, accessible via Start, All Programs, Accessories, System Tools Backup. NT Backup capabilities: full, incremental, differential, and daily backups. Backup to disk or tape devices, scheduling via Task Scheduler, backup of system state including registry, comp plus class registration, boot files, Active Directory if applicable, certificate services, sysvol for domain controllers. 12.3 Types of backups. Backup type description: full. Backups all selected files and marks them as backed up, most time and space consuming. Incremental backup: only files changed since the last full or incremental backup. Fast but restore requires full, all incremental sets. Differential: backup files changes since the last full backup. Restore requires full, latest. Differential: daily backup files changed on current day, does not reset archive bit. Use a combination, e.g. full on weekends, incremental daily for balance. 12.4 Planning your backup strategy. Step-by-step approach. 1. Identify critical data, shared folders, database, system state, application data. Determine backup frequency based on RPO, recovery point objective. 3. Choose backup destinations: tape drives, external hard drives, network shares, NAS, offsite cloud storage via third-party tools. Schedule backups during off-peak hours. Document the backup schedule and retention policy. Test restores regularly. System state backup. A system state backup is essential for restoring Active Directory for domain controllers, boot files and system registry, COM plus applications and configurations, certificate services. To perform a system state backup, 1. Open NT backup. 2. Choose Backup Wizard or Advanced Mode. 3. Select System State under My Computer. 4. Choose the destination and run the backup. 12.6 Performing a restore. 2. Restore data. 1. Launch NT backup. 2. Click Restore and manage media. 3. Select the backup file and contents to restore. 4. Choose restore location, original or alternate. 5. Review and confirm options before execution. System state restore caveats. Require boot into directory services restore mode for DCs. Use with caution, overrides important settings. 12.7 Disaster recovery scenarios. Scenario 1 File loss. Restore individual files or folders from backup media. Scenario 2 Active Directory corruption. Boot into directory services restore mode. Restore system state from last backup. Scenario 3 Total system failure. Reinstall Windows Server 03. Restore full system backup including system state. Reconfigure networking and applications. Scenario 4 bare metal recovery. Requires third-party tools or full disk imaging tools. Acronis Symantec. 12.8 Tape versus disk-based backup criteria. Tape disk. Speed, slower, faster. Cost, lower per GB, higher per GB. Longevity, years limited. Portability, yes. Medium. Automation, good with autoloaders. Good script software. Use disk to tape, D to D to T, or offsite replication for layered protection. 12.9 Using Volume Shadow Copy Service, VSS. VSS allows users to access previous versions of files without needing IT support. Enabled or shared folders. Users can right-click file folder properties previous versions. VSS copies are made at set intervals, e.g. twice daily. Not a substitute for full backup, but useful for quick recovery of recent changes. 12.10 Backup best practices. Use a 3-2-1 rule. 3 copies on 2 types of media, 1 offsite. Encrypt sensitive backups. Rotate media and label clearly. Document restore procedures and access rights. Monitor backup logs and alerts daily. Summary. Windows Server 2003 provides a solid backup and restores capabilities through NT backup and system state features. However, a good backup plan goes beyond tools. It includes careful planning, frequent testing, media management, and user education. Without a robust backup and recovery strategy, you can ensure continuity even when disaster strikes. So I'm going to leave it here today for this section of Windows Server 2003. So our next videos lives will be more in depth, and it'll be Windows Server 2003 administration. So I hope you like this video series. Thank you again and have a nice evening.